Welcome back at C Square. In this lesson we will talk about angle pairs, and I said here there are different kind of angle pairs, so let's see them. So the first one, adjacent angles, like this one. You notice they have what we call a common vertex, like in this case the vertex is this point A, a common side, these sides A and this ray A and they have no common points. You notice these two angles, this angle and this angle, they have no common points. We call them this adjacent angle, these two angles. Non-adjacent angle, I said here, MAN, this big angle, this angle here, and MAD, the big angle, right? They do not pass these no common points. They have something in common, which is the angle MAN. Also, you have another example here of non-adjacent angle. These don't have the same vertex. Vertical angles are non-adjacent angle. Very important, remember this, formed by two intersecting lines. So you notice here we have two intersecting lines, the line TM, this one, and NP, this one, and they intersect at point A. We have two pairs. One is TAN, how I said it, right here, this angle, and PAM, this angle. You notice I marked them the same because these angles are congruent. Now we have another set, this one, TAP and NAM. And you notice I mark them differently, but these two angles the same, marking two arcs, so they are congruent. In this case here, we do not have vertical angles. These are not two intersecting line. We have here this ray BR and BG. They don't form a line, so no vertical angles. Very important. A linear pair looks like this, the one on the left, this picture. You notice they have a common vertex here. They are adjacent angle, and these adjacent angles form a line, and these two angles form a linear pair, this one and this one. They are not congruent. They form a line, and that's important because that means the sum of the measure of these two angles, if we add these two angles, we get 180. Very important, this is an example of non-linear pairs because they do not form a line. So let's take a look on this first example, and I need to name two adjacent angles. So we have plenty of choices here. Let me start with these two angles. They are adjacent angle, so I'm gonna write here angle FBE and angle EBC. Those are adjacent angle. I'm gonna give you one more, but you can find more adjacent angle probably. I'm gonna say this angle here and this angle here. Those two angles are adjacent, and in fact, let me change it since we do not have I cannot name one of the angles, so I'm gonna say maybe, yeah, let's say this angle and this angle. Okay, and this point here is F. So what will be those two angles? Angle AFD and angle AFE. And if you want to say, hey, but these two angles also form a line, they are a linear pair, that's correct. Let's take a look to part B. On part B, we need to name two vertical angles. So remember, we need to find two intersecting line, and we do have something like that. We have line AB or segment AB, if you want to call it, and segment DC. You notice we have these two angles, for example, are vertical angles. So let me write that here: angle AFD and angle EFB. And I'm not so sure if I mentioned that these two angles are congruent. I think I mentioned, yeah. These two angles are congruent. They are vertical angles. They have the same measure. Do we have another set? Of course we do, and these are going to be these two guys. This one here and this one here, which is going to be what? Angle AFE and angle DFB. These two angles are vertical angles. So let's see to the last part of this problem. Name a linear pair, and if you remember, I named already one. It's angle AFD, this one here, and AFE. We did that in the first part. Oh, let me write them again. AFE and AFD. And do you remember what is important about these two angles? If we add the measure of these two angles, the sum of these measures will be 180. Do we have another set of angles that form a line, linear pair? Yeah, this one, which is congruent to AFD, and this one. Yeah, they still form a line. So I'm gonna write EFB and BFD. Okay, remember the sum of the measure of these angles is 180. And we do have more in this picture you may want to look for. I said here two important angles pairs are what we call complementary angles and supplementary angles. Complementary angles are the angles whose measure have a sum of 90 degrees. They can be adjacent and non-adjacent. In the first picture here, you see these two angles are adjacent, how we call them. They form a 90-degree angle. You see the box here. Okay. On the other hand, in the second picture, these two angles are not adjacent. However, 30 plus 60 equals 90. They are complementary angles. So remember, they can be adjacent and non-adjacent. The sum of the measure is 90 degrees. Very similar, supplementary, the sum is 180. They can be adjacent, like in this case here, these two angles are adjacent and they form a line, so we call them also a linear pair. And they can be non-adjacent. You notice here 65, 115. Yeah, these two angles, if we add them, we get 180. These angles, we call them supplementary angle. Now let's take a look to a problem. Find the measure of the two supplementary angles. If the difference between the measure of the two angles is 25 degrees. So let's call them angle A and B. So I'm going to say the measure of angle A plus the measure of angle B equals 180. Right, that means this statement here, supplementary angles. And now we know the difference between these two angles is 25. So I'm going to assume angle A is the largest one. So I'm going to say the measure of angle A minus the measure of angle B equals 25 degrees. Okay, so now can I find the measure of these two angles? depends how much algebra you know. Let's say if you know the system of equation is like you can simply use elimination, but let's say you don't know that. I will say let's solve for angle A here, and I'm gonna subtract angle B. So measure of angle A equals 180 minus the measure of angle B. And now I'm going to take this expression and replace it in the second one right here. So I'm going to have 180 minus the measure of angle B minus the measure of angle B equals 25. So we have here 180 minus twice the measure of angle B, combine the two like things here, equals 25. So then I'm going to subtract 180. I think that's the easiest way. And I have 2 times the measure of angle B. And yeah, you should expect to get a negative value here on the right side. So 25 minus 180, that will be negative 155. And we're gonna divide by negative 2 here. And we have the measure of angle B equal 155, well, negative 155 divided by negative 2, 77.5 degree. And now we need to find the measure of angle A. We can go on any of these two relations. Let's say go on the first one, and we have the measure of angle A. In fact, I can use this statement here. Is 180 minus 77.5. And that will be 102.5 degree. A very similar problem, but now we know angle M and N are complementary. The measure of angle M is 33 degrees more than the measure of angle F. Find the measure of angle M and angle N. So very similar. We're gonna start with the first statement, the measure of angle M. The measure of angle M, let me rewrite that, M plus the measure of angle N equals 90 degrees. That is the statement. And now let's go to the second one. The measure of angle M is 30 degrees more than the measure of angle F. How are we going to write that? We're going to say, hey, measure of angle F. Okay, I should have said M here. So this one is M. In fact, the measure of angle, in fact, that is N. I apologize for this. So N, measure of angle N plus 33. Okay, so now we're gonna take this expression and replace M, measure of angle M here. So we have the measure of angle N plus 33 plus the measure of angle N equals 90. So we have here these two guys that are alike, and if you do not like this measure of angle N, you can just simply X, call it X. So we have 2 times the measure of angle N plus 33 equals 90 degrees. I'm going to subtract 33 here on both sides. And I have 2 times the measure of angle N equals 66 divided by 2. And we have the measure of angle N is 33 degrees. Okay, and I apologize, I have a mistake here. This is not 66, is 56, right? In fact, 57. Let me double check. 10 minus, yeah, 9 minus 3. No, it's 67. 57, right? So we have here 57 divided by 2, and that will be 28.5 degree. This is the measure of angle N. And now we can move and find the measure of angle M. Go back in the first statement here, measure of angle, I mean in the second one, this one here. And we have the measure of angle N, 28.5 plus 33. The measure of angle M is 61.5 degrees. Okay, and one more time, if you don't like this statement like this, you can call us x and y and write the equation using this classic variable. Let's take a look to the next part of the lesson. We talk about perpendicular line here. Perpendicular line intersect and form 4 right angle. You see here in this picture, by the way, this is the statement, line NP, perpendicular line MT, and you see these 4 right angles, 4 boxes, right? However, just be careful, most of the time you are not going to see all 4 boxes. You don't need it, you just need to see one. And you know all the 4 angles are 90-degree angles. This is going to be 90 degree because it's a vertical angle of the one that is marked. This one is going to be 90 degree. Form a line. This one is going to be a 90-degree formal line. But like I said, you will see only one box. One box is good enough. So let's take a look to this problem here. Find the measure of each angle in the figure if the measure of angle DAE is 55 degree. So let's take a look. Angle DAF, that's the first thing. But let's mark some things here. DAE 55. This one. This one is 55 degrees. Okay, and we need to find first the measure of angles DAF. Oh, that is pretty easy. How much is going to be that angle? That will be 90 degrees. And let me show you why. If you take a look, DAF is this angle, which is adjacent, if you want to call it, but the best way you call it, a formal line with this angle that is marked like a box, 90 degrees. So obviously this angle here, it's going to be 180 minus this angle, which is 90. So that's the reason it's 90. Okay, so let's take a look to the second part, B, the measure of angle EAF. So now we can find this guy because, like I said in the first part, this angle here is 90 degree. How are we gonna find that one. Remember, this guy I mark it at the beginning is 55 degrees. So the measure of angle EAF will be 90 degree minus the measure of angles DAE, which is 55. So that will be 90 minus 55. That will be 35 degrees. Let's take a look to the measure of angle CAB. CAB, this is the angle. I'm going to mark it with one arc, but I want to be sure it's not congruent to the other angle that is marked with one arc. So let me erase the things here. Too many things. CAB, that CAB is congruent to what angle? With this angle. They are vertical angles. If you remember, this one we did find out is right here, EAF, and it was 35. So this one will be 35 degrees. Vertical angles are congruent. And the last one, BAF, which is this angle. Again, I mark it with an arc here, but I'm going to erase the other. So how much is going to be that angle? Oh, we can look, and I just erased that guy. This one was 35 degrees, and this one is supplementary of that one, right? Because they form a line. They form the line CF. So that will be 180 minus 35. So let's see how much that is. 180 minus 35, and that will be 145. Okay, so you see in this problem we use all kind of relation between these angles, complementary, linear pairs, adjacent, things like this. And now, very important, in any problem you'll have to find information from figures, and there are some things you can assume, like what? Angles are adjacent. You can see that in a picture, you can assume that. Angles form a linear pair, you see that. I use these two things in the previous problem, and also angles are vertical angles. Yeah, in the previous problem the picture allows me to get this information. I can assume those information from the picture. However, there are things you cannot assume. You cannot assume that an angle is a right angle because it looks like, or the lines are perpendicular. You cannot assume angles or segments are congruent or angles are complementary. They need to be marked on the picture in order to assume things like this. Other than that, don't assume. So let's take a look at this example where we have to use this figure below and see which statement can be assumed, true or false, if you want to see something like that. So let's take a look to the A, angle ABE. We notice is this angle marked already with a one arc, and angle CBD. Are these two congruent? Yes, because they are marked the same arc. So this one I'm going to say yes, you can assume. Okay. B, angle BAC, which is this angle here, and angles DAC, which is this angle here. You'll notice I mark them different. Are these two angles congruent? They look like, however, we cannot assume. No. One more time, they look, but we cannot assume. On the other hand, on part A, we see they were marked the same. Now, later in your classes, you'll learn how to prove if that's the case, if those two angles are congruent. But so far, looking to the picture, we cannot say that. We're gonna go with no, we cannot assume. Let's go to part C, which says angle AEB, AEB. Let me erase these two guys. I'm gonna move to the next one, AEB, which is this angle, and angle DEC. Are those two angles congruent? And the answer, yes. We can assume that from the picture because these two angles, they are vertical angles. So this one you can assume because we have two lines intersecting and they form vertical angles. Let's go to part D. We want to know if the measure of angle DCE, which is this angle here. Again, I'm going to mark it to like this, and angle BCE is 90 degrees. Okay, which is this one, BCE. And if you notice, yes, we can assume that. Why? These two angles are adjacent, we can see in the picture, and they form this right angle, this box here. So yes, this one can be assumed. They are not, we cannot assume the angle are congruent, but looking here, we can see the angles form these right angles. Let's go to part E. Part E says angle BEA, which is this angle BEA, this angle, again I'm going to mark it like that, and angle BEC, this angle. You see I marked them different. Are adjacent and supplementary. Yes, they are adjacent because they have this common vertex, they have the common side, they do not have common points, and they are supplementary. Yeah, they form the line. So both things can be assumed for part E, so adjacent and supplementary, and also a third thing, they form a line. Okay, let's go to part F. And again, I'm going to erase because I don't want to have too many things. Angle EAD. This angle here, again I'm going to mark it like this, is congruent with angles EDA, which is this one. Another statement, they look very congruent, but we cannot assume that. No. Okay, and let's go to next statement. AB, the segment AB congruent with segment CD. AB, oh, it's already marked. You see it, and CD. Are these two congruent? Yes, they are marked on the picture. We can assume that. And let's go to the last statement. Last statement, B, segment BE congruent to ED. BE, it's this one. We mark it with 2 like this, and ED. Another very interesting statement. They look very congruent. I'm gonna say something like that. But can you assume that? No. Okay. So again, it's very important in your geometry problem to know what you can get from the picture and what you cannot get from the picture. Okay, let's take a look now to this example. Use the figure below, find the value of x if the measure of if angle PTN is a right angle. So PTN is a right angle. You may want to mark that on the picture. Okay. So now it's given in the problem, mark on the picture so you can see that better and you can use it later properly. And the measure of angle PTR is 3x plus 12, and the measure of angle RTV 2x minus 7. So PTR and RTV. Oh, these are these two angles. You see, I'm gonna mark them different, but what do you notice about those two angles? They are adjacent. First thing, maybe you can say that they have the common vertex T, the common ray TR. They don't share any common points, but also if we add these two angles, we get 90 degrees. I'm gonna make this big box one. And why do we get that? Because these two angles form a line that are linear pair, and this is 90. This one is gonna be 90. So that's the thing I'm gonna start with here. I'm gonna say the measure of angle PTR plus the measure of angle RTV is 90 degree. I can write this statement. I know you see I have the first part of my geometry is in the picture. I kind of taken from the picture. But now I'm going to replace this with this measure of this expression, and we have 3x plus 12 plus 2x minus 7 equals 90 degrees. And we have here 3x plus 2x, which are alike, that is 5x. 12 minus 7, those are alike, so that would be plus 5 equals 90. Two-step equation, I'm going to subtract 5. So I have here 5x equals 85, and the last step, divide by 5. So I have x equals 17. So that's the first thing we need to find out. Find the value of x, and that's it. We done the problem. Let's take a look to the next problem where we have a very similar picture. You see how similar the picture here. But it might be different, so do not assume things from the picture unless they are told you in the problem or they are marked on the picture. So let's take a look. Use the figure below, find the value of y if the measure of angle NTP, oh, this angle here, and you see I'm not gonna make it at a right angle like in the other problem. I don't know that it's 3y plus 12. And the measure of angle PTV, which is this angle. And you see, I'm gonna mark it different because I don't know if they are congruent. Is 2y minus 7. So please do not say any of these angles is 90 degrees. You assuming things that might not be true. But what can you say? Well, I can say that these two angles together form this line NV. They form a line, they are a linear pair. So that's my first thing I'm going to say here. The measure of angles NTP plus the measure of angles PTV equals 180 degrees. They form a line, therefore they are supplementary. So now we're going to replace with this expression 3y plus 12 plus 2y minus 7 equals 180. So very important you notice even the problem looks similar, the problem is different. So we have here 3y plus 2y, it's 5y minus 5. So the problem look very similar as the math, however it is different. I'm gonna say one more time. I'm gonna add 5 here. In fact, this is plus 5 here. I apologize. So we're gonna get the same value for y like for the x in the previous problem. And I have 5y equals 175 divided by 5. I have y equals 3 and 15 divided by 5. 33. Let me double check. 175 divided by 5. I might be wrong. Sorry. 35, not 33. Let me go back a little bit to the other problem. Yeah. So you notice they look the same, however, they are different. They are different. We found the value of y. Now, you can find these two angles now. You can find this angle and see if it's a right angle. NTP, it's 3y plus 12. 3 times 35 plus 12. No, that is 117 degrees. So you see, the picture is not accurate. That's another thing that you need to be aware in your geometry classes. And the third problem, that looks so similar with the other, same picture. However, you'll see it, the approach is gonna be different. So again, be very careful. So in this problem, we have use the figure below, find the value of z if the measure of angle NTM is z plus 24 and the measure of angle RTV is 2z minus 7. So NTM is this angle here and RTV is this angle here. Okay, you see I marked them the same one because these two angles are congruent. They are vertical angles. So I'm going to write that here, measure of angle NTM equal to the measure of angle RTV. Why? One more time, vertical angles. And now I'm going to go to the algebraic part of this problem. I'm going to replace z plus 24, that is the measure of angle NTM equals 2z minus 7, and that is the measure of the other angle RTV. So now how we're gonna solve this one? Many ways. I personally will subtract z to get rid of this z. Don't forget to do that on the other side. And then we have here 24 equals just z minus 7. I'm gonna add 7 to get rid of this, minus 7. And I have 24 plus 7, that is 31. Z is 31. And that's it. One more time, you notice here we have talk about angle pairs and how you can use them, and also what you can assume from the picture, what you cannot assume from the picture. It is very important. If you enjoy this lesson, don't forget to click the like button and come back on C-Square for more help. Thank you.